In this edition of Fluid Life Unfiltered, your host, Sean Patrick Craig, account manager at Fluid Life, chats with Brian Harris, owner of TriBoro Consulting. Brian is a seasoned professional in reliability and maintenance within the pulp and paper industry and shares insights into the pivotal role of oil analysis in ensuring operational efficiency and mitigating risks in machine maintenance.
I would like to first kind of bring the first question to Brian here. Tell us a bit about yourself and kind of your professional journey so far.
Okay, so if you haven't picked up by now, I'm actually from England to begin with. That explains the accent. Been in Canada for coming up 25 years, anniversary in July. Looking forward to that. So prior to my time in Canada, I was actually a marine engineer. So most of my time was spent outside of England, traveling the world on merchant ships as a marine engineer. Canada came in, like I said, 1999. Worked in a number of industries, food industries, metal industries, oil and gas, and last but not least, pulp and paper.
And when and how did you first become involved with, the whole reliability and maintenance role?
That's a good question. I think of reliability and maintenance as two separate issues. They kind of dovetail together, but reliability is kind of like if I give a definition of maintenance reliability, maintenance is basically preservation of function. Reliability would be mitigation or limitation of failure consequences. So two separate things, but they're tied together. So I've been involved in maintenance in that respect since I first went on a ship. You maintain them, you're operating, and you hope it's reliable. But my first role with reliability in the title was as a reliability engineer at Tech Cominco, which is in Trail in BC. That's a lead smelter, zinc smelter place. Obviously, very complicated processes, but that was my first position as a reliability engineer. And since then, I've bounced from being a reliability to maintenance, reliability back to maintenance. So they are dovetailed together, but that's basically how I look at them.
Okay. And you know what? I think that puts you kind of at a very unique position. They give you that great insight from being on both sides of the fence there on the reliability and maintenance side to know exactly where that cohesion is. And, over the decades that you've kind of been working in those two fields, you probably have seen a lot of things that work and don't work, that could be better, or that you personally have seen gone a lot better. And, over your career, what have you learned that were key tools for yourself as a reliability professional and maybe for others kind of in general?
As a reliability professional, I think your key tool is basically patience. It seems to me like, and I've seen this lots, that you always have failures, you always have issues. It's kind of how you manage those failures. And what I used to hear in a morning meeting was somebody would pipe up, oh, it's a reliability issue, give it to the reliability guy to look at. See, everything's a reliability issue, but that's the way they look at it. So yeah, it's a difficult job to look at. It depends how complicated the industry you're in. It's like oil and gas, it's all big machinery, it's lots of rotating equipment, and it's believe it or not, it's quite simple to deal with. But in something like a pulp and paper, there's lots of chemicals involved, lots of complicated processes, controls. It seems like the more complicated the process is, it seems the less likely it is to fail unexpectedly. Chips, on the other flip side of that, chips are quite reliable. They're built that way for a reason. It's you don't have access to unlimited spare parts or access to subject matter experts. Chips are built to be reliable, and that's basically so they can get from one end of the globe to the other without failing.
Okay. And kind of throughout your career, I've heard of, the trifecta, the triangle of kind of reliability tools, and it being vibration analysis, heat diagnosis, and kind of as well as using oil analysis. What was your experience in kind of using oil analysis throughout the years, and value that you have seen it?
Well, basically, there's three different types of companies where I've, in my experiences, those that don't use oil analysis. There's those that take oil samples and don't look at the data, don't react to it. And there's those that take the samples and look at the data and do something proactively with it. So I look at it, if you take an oil analysis and you're looking at the data, you've got to react to what that data is telling you and fix those issues. So the second one, the one that takes the oil analysis, doesn't look at the data, doesn't react to it, they'll probably save money by not taking the oil sample to begin with. But and I say that because when I've worked for companies that do perceive they have an oil analysis program, when you look into it, they don't do the follow-up, they don't do the corrective actions.
And so when you say save money, do you mean saving money on the part itself, getting longevity out of the part, and saving money on time, or, perhaps something doesn't need to be addressed right away, making work orders more efficient? Do you mean it on kind of those two aspects?
Well, the second one, if you're taking an oil sample and you're not reacting to it, why are you bothering to take the sample? You've got to analyze it. What do I need to do to correct it? Whether it's water contamination, dirt, or it's additives are gone, but you've got to do something if you get a sample result that's classed as abnormal. And I've quite a few companies I've worked for or have looked at, for some reason, don't seem to be doing that.
So kind of the companies you worked with, I know that there are some, it sounds like, that didn't take advantage or the approach of analysis, and obviously some that have. And the ones that have, I think you yourself, in the role you were in, you presented them and made the case of the value in using kind of oil analysis.
It's the tool that is probably most underused on the MyLab program, which is the Fluid Life Oil Analysis, is the dashboards. You go, well, that basically, if you look at the dashboards, look at the data, you get an holistic, high-level view of what's happening with your program. And if you're not looking at that data and reacting to it, it doesn't matter if you get one or two oil samples. I'm talking about the program in totality. It's like, then you know you've got a problem. And if you know you've got a problem and you can present that data to management, you build a case to basically put the corrective actions in place, whether it's upgrading your lube room or upgrading equipment or buying filters or buying breathers. And actually, in some cases, like this has happened with the bulk oil systems with 8 to 10,000 litres of oil in it. It's a big expense, but if you look at it and go, and you've got a serious problem with this oil, you need to change it. You've got to show the data to convince people to do that. They're not going to spend $100,000 on a bulk oil change without somebody showing them the data to support that.
Yeah, you're right. Yeah. And you know what? I think you kind of highlighting the fact with whenever it comes to a kind of a program or someone speaking to, and it comes to, okay, oil analysis, what's the first link in that chain of oil analysis? And I always emphasize on how taking a proper sample, and once you do it, because you're going to get, clear data as to what's in it. But that also falls into the second part of it is, do you know how to read the data? That's where the value. If you do all this and you're not sure how to interpret data, what are you looking at? Then it's hard to know, what's your next action item? Am I doing 100K drain and fill on my reservoir or not? How does, without knowing exactly what that data means, how can it change kind of your day-to-day tasks, or using it for a program-wide insight? I know for yourself in your position, you've kind of overcome that. You seem well educated into knowing the importance of taking a proper sample, and as well reading the results. And it sounds like you're putting strong emphasis on that. how did you kind of use oil analysis? You got the result to your desk, you read it. How did you use it for day-to-day tasks? Just simply, what did that change to what you were going to do that day, or a more of a big program-wide insight? Like, how did it give you clarity as to how is the equipment functioning across your entire site?
On a day-to-day basis, most of the problems you come up against is contamination, whether it's dirt or water. I'd say 95% of those issues are common in most industries. So it's how you deal with those water ingress issues, dirt issues, and that. Then you get the 5% where you go, and as an example, I had samples that come back and we'd had increase in copper. So the copper was kind of not going up linearly, it was going up exponentially. So copper in itself isn't really a big issue. 10, 15 ppm, it's not a problem. But when it starts rapidly increasing to 80, 90, and then kind of, like I say, exponentially, you've got a problem with a piece of equipment. And this is a case, an example is that the pump was failing on an hydraulic system. The vibe guy didn't pick it up, didn't see a problem with it. But I said, well, it's obviously the pump. What else has got copper in it? Took the pump out. It was basically worn out. It was like about to fail. So that was an example where oil analysis picked up a failure and vibration didn't. And I've seen that a number of times, especially with slow moving pieces of equipment. It's like it doesn't generate the energy to create the vibration to send you any warning signs you're going to have a failure. So things like that, that's the 5% they're going, okay, these are different. These are outside the normal, just dirt or viscosity or things like that. It's how you trend those issues and come to a conclusion that something's about to fail. So trending is key, and that's when you get into how often should I pull a sample? Well, once a year is probably not good enough. Once every 3 months, maybe, but once you start seeing a trend, then you increase the sampling frequency. So I always say that the frequency of sampling is dependent on the trend, the criticality, and what you're seeing in the sample results.
Yep. And you bring up a couple of good points there, where one, sampling kind of on a scheduled manner, because the data trend is key. It's hard to assess what you want to do on something without knowing, do the results look normal, nominal, excessive, concerning for a component if you only tested once ever or once a year. If you at least provide, a couple of samples, and you get an idea of the trend of where it sits and lies. You kind of also mentioned an important aspect with oil analysis, vibration, and checking for heat, where just because you do two doesn't mean you don't need to do the third. That there's a blind spot that's left if you kind of don't perform all three, where the vibration didn't show anything, and that's what you're mentioning, but the oil analysis showed presence of copper. So it kind of showed a preliminary issue before it even was apparent on the vibration side, that it caught it kind of that early. And I've kind of encountered a couple of times where people mentioned, they do two, so they don't need to do the third one, and the reality is, a kind of a really fulfilled, predictability, reliability program. Usually you want to try and get all three, and to do it on some sort of regular basis to really know, where things stand with your program. So, I mean, it seems like you come across all these aspects in the different professions that you've been in. You've seen a lot in your industry, in different industries, not just one. Pulp and paper was your latest one. What are some very clear examples, beside the ones you just provided, some clear examples that of oil analysis providing, a great level of success, catching a failure like that pump was one of them. Or maybe, confirming mediation efforts like, hey, we're going to try and clean up this thing. Let's track it over the course of a month to see if it works. Something that was definitive in cost savings, something, concrete.
The best example of cost savings I can give you is what happened to me when I was at Suncor. which was the first time I started with working with Fluid Life. I think it's fair to say they had issues, but they didn't know what those issues were. It was kind of it was an old plant. I worked in the powerhouse. Lots of steam leaks, lots of coke dust in the atmosphere. They had an oil sample program, but it was the version number 2, where they take the samples, send it off, and didn't look at the data and analyze it and correct it. So I'll try and make a long story short. So in a period of about 4 years, basically looking at the data, doing the quarterly reports, asking management for money to fix these things. In other words, breathers, filters, proper storage and handling, the whole best lubrication, best practice philosophy. Training was involved in that as well. We had people coming from Fluid Life to give the guys training. So a lot of expenditure, resources, time, in equipment. It was upwards of $5 million to kind of, as an investment, to fix those issues, which is, to some companies, that's a lot of money. To an oil sands industry, it's a drop in the bucket. It's not a lot of money, but it's still a big investment. So over that period of time, we reduced maintenance costs by about 30%, which is a huge amount of money. But on top of that, we increased production by 18%. So to put that in monetary terms, the basically 18% increase in production, in steam production, resulted in 18% increase in oil production. So when you're talking like 300,000 barrels a day and you take that to 350,000 barrels a day, you're making an extra 50,000 barrels a day of oil based on your steam production. It equates to an increase in revenue of over $1 billion. So your net return on investment is, like, for every dollar you spent, you're getting $32 back. And that was probably 95% of that was all down to the oil analysis program, looking at the data, putting the corrective actions in place, and then seeing the improvements. Less failures, more production. It's kind of I'd say that was money well spent.
Yeah, no kidding. Yeah, it sounds like that one there, you're attributing a lot of the success to, sure, savings in parts, but also the increase of productivity. That's a pretty good point. You're saying 95% of it was because of just kind of engaging that oil analysis.
Yeah, it was, look, you're going, well, what are you doing? Are you putting water in the equipment? And like you say, when their attitude was, well, we'll just drain the water off. I said, well, why don't you stop the water getting in the equipment to begin with, right? So it was, like I said, it was an old plant, and lots of steam leaks, lots of coke dust in the air. So if you don't have good contamination control, that just worked its way into the equipment. It's like it was from an environmental issue, like cleanliness, it was basically horrendous. It was just, well, no wonder the equipment was failing prematurely.
Okay. And you know what, that kind of raises my next question is, if someone was tuning in and listening and they're like, okay, what oil analysis, it sounds great. It can help me out. What would be kind of an easy lubrication practice that I could start implementing into my program? Like something quick and easy that would kind of have a big impact that I could pick up on oil analysis. What would be your biggest and just easiest suggestion? It sounds like contamination control is like step one, but I'll leave it to you to explain.
I could say pre-filter your oil, put a breather on, start an oil analysis program. All of those are one item as a suggestion. But what I would suggest is start with an audit, start with an assessment. And it could be bringing a third party, doing an assessment. You can actually do free assessments online. Nor you have one test case out when you go and do your self-assessment. Do we have this? Do we have that? And then it prints out a score sheet and tells you where you're lacking. So that's basically what I had to do when I was at Suncor, was bring in Fluid Life to do an audit, give me a recommendations of like a 35-page report saying this, and this is what your problems are. And obviously every audit or assessment comes with recommendations at the end of it. And then you present it to management saying, this is an opportunity and this is what we need to do to fix it. So my suggestion is do an audit, and they're relatively cheap. You can get them done online for free, or bring somebody in, which is the best way to do it, because they'll be classed as a subject matter expert, and they will give you the basic, the back and the document to make all those changes.
Yeah, and that makes perfect sense. You know, like if there was, before you want to go around start putting out fires, you got to know where they are. And it sounds like having the audit is going to direct any effort and energy you have in a more efficient manner, because you're going to tackle the first issue, the biggest issue first. It sounds like, it sounds like when you're mentioning kind of lubrication controls, like that can mean a couple things: filtering your oil, maybe desiccant breathers on key units. But before you can even know to do that, assessment first. You need to know where you need to put your attention to. Where's the smoke coming from?
It gives you a roadmap. It gives you an action plan. It gives you something to work to. And without that, you're just going from fighting one fight to the next. It's just, it gives you a document to take to management saying, if you want things to improve, this is what it's going to cost you. This is what we need to do. So that's why I say, get an assessment done first thing.
And that's definitely something you can help with as much all the knowledge, experience you have, that you're now in a position to help people with those kinds of assessments, that, you know, you're bringing forward tons of know-how and firsthand experience. And yeah, for sure. At the end of this video, I'm definitely going to link whoever would like to contact you to get to pick your brain more on the matter. For sure. I think you definitely could help whoever reaches out. Now, kind of coming back to the last industry you were in, which is one where, you know, my experience and correspondence with you started, was the pulp and paper industry. So just to kind of recap, you know, what was your experience with the pulp and paper, and, you know, how was it with that industry?
It's very similar to every other industry. They've all got pumps, they've all got gearboxes, hydraulic systems. I'd say one thing that impressed me was the size and scale of the paper machines. If you've never seen a paper machine, these are massive piece of equipment, and lots of failure points, if you want to call it that. So yeah, it's different, but it's the same. It's all rotating equipment, all needs grease or oil, and but it had its challenges. It was again, the plant I worked at, it's an older plant built in the 50s. Lots of reliability issues, if you want to put it that way, but something we worked through. And I'd say this, they thought they had an oil analysis program, but actually they didn't. They had two of these spectrum like desk analyzers, but they were 1990s technology that didn't work that great. But that's basically, actually, when I started at that particular plant, I started as a reliability specialist, and then change over to the looking after the lubrication program to basically kind of give it some direction, for want of a better word, is get things on track. But it was I enjoyed it. It was lots of success and huge commitment by management. It was a big investment on not just the oil analysis program, but the equipment, the lube room, the training. It was they understood, they bought into it, and we seen the successes.
And when it comes to pulp and paper, you know, are there specific challenges to that industry and into the lubrication use? I mean, first assumption is tons of water, probably humidity, water issues, heat issues. But from your experience, what are just very common big challenges with the pulp and paper industry, and just on the lubrication?
Yeah, you actually hit on it there when you said water. They had a lot of water ingress issues. Primarily, breathers didn't have the correct breathers on equipment. And breathers don't only just stop water, they stop the particulates. So when we did start the oil analysis program, by the time I left, I think we had about 400 400 different components we were sampling, because there might be different components on the same machine you're sampling, like a washer would have bearings, gearboxes. So I'd say probably approximately 400 pieces of equipment we would sample. And of those 400 pieces of equipment, I'd say more than 50% of them required some kind of corrective action to bring the lubricant back to an acceptable standard. And I used to do this, track it in a KPI report, and it was something in the region of 17% of those pieces of equipment had water ingress issues. So without an oil analysis program, you don't even know that. You just assume that your oil's okay and it's clean and dry, when in actual fact it isn't.
Okay, so that's kind of where the oil analysis helped with those challenges, is to identify that was the issue.
Yeah. Well, you see, if you're not testing your oil, how do you know?
Yeah, but then you don't know. And kind of for pulp and paper, what would be your first suggestion for the reliability folk in that industry?
Same as any other industry. Get an audit done. Have a look at your program. Do the assessment, build a roadmap, and then follow the roadmap and make those corrections, and then you'll see the results.
And you obviously have quite a history with Fluid Life and our oil analysis team here to date. How have we helped you with your journey up to this point?
When I started looking at oil and all, kind of realizing there was an issue, is that you need those people who've got the experience, who have the answer. When I start, I'm looking at an oil sample result, I'm going, I have no idea what 90% of this means, right? And you're talking about flagging limits and additives and all this. It's like, and that's how I basically got involved with Fluid Life, was asking those questions, and they're giving us the guidance. It isn't just about sending them the sample and they send you the results. You have a team that basically supports the program. And at one stage at Sunco, I basically had the guys on speed dial. It's like, okay, I need this, and you're more than those are the guys with the experience. And I still do that now. You basically build up a network of people, experts with more knowledge than me personally, and if you've got any questions, it's basically those are the people you go to and get the answers.
Yep. Yeah, and that's kind of, that's what's great about having you on here and kind of discussing, everything about kind of your reliability, oil analysis up to date, is because you do have that knowledge, that you do have that experience. And so when someone's like, who do I even ask? Do I have the right individual to ask? That's kind of half the battle, is knowing the right person, having the right support. And I'm glad that we were able to kind of help you out in your endeavor so far. And I know you were a pretty good power user of our MyLab web portal, where there's functions in there that you specifically use to kind of trend the data in terms of the KPI improvements, in terms of that program-wide insight. Have you found kind of using MyLab and kind of Fluid Life together as a nice entity together to have as a tool?
Well, that MyLab the reporting function, the dashboard, that's a great tool. And I say that because when I started this journey at Suncorp, and I was looking at data, and you didn't have that functionality in the MyLab program. So for me and I can remember getting the data, doing a data dump into a spreadsheet, doing pivot tables, making nice fancy graphs and all this, and it used to take me 3 or 4 days to put that report together. And it was, like I say, labor intensive. Now you've got that dashboard, it basically takes you 10 minutes to put that same report together, because it basically, you click on whichever graph you need, you customize it, you expand it to whatever timeline, then you go quarterly or yearly, and then you basically just take a screenshot of the dashboard. It's so easy, and it's kind of, when you present that to management and saying, these are the improvements, this is the things we need to work on, these are the problem areas, they go, fantastic. Like I say, it's probably the most underused tool in the MyLab program, I'm guessing. It's I say that because I've done reviews of other companies' MyLab, the program, and I've looked at it, I'm going, do you even look at this? Do you use it? And the answer is not really, no.
Well, at this point, to kind of recap our conversation so far, it sounds like kind of the first suggestion, most important suggestion aspect that you would offer to someone in terms of if they wanted to start an oil analysis program or know where things are in their current one is assessment. Without that assessment, without that kind of audit, that you're kind of left wondering where you need to put your attention to, and pair with that, use oil analysis to make sure that whatever comes with that assessment, you can track the improvements of it.
Yeah, you gather the data, and it's not a small feat to have what I call a robust oil analysis program. It takes time. There's lots of roadblocks, there's lots of hurdles you've got to jump over to get something that's kind of worthwhile, and it takes years to kind of build that program up. And what I find when I've looked at other companies' programs is they actually start it and then they give up on it. It's like they'll take samples for a period of a year or 2 years and then they'll stop. This happened when I was at the last place I worked, Pulp and Paper. It went 1998, they took some samples, 2003, then 2013. I'm going, and I talked to the guy who started it the last time. He used to come back. I said, well, why did you stop? He said, oh, it was just too much. I said, well, you start something, and when you get down to it, he says, well, I didn't really see any value in it. I said, because the people who do that don't have to analyze the data, what the corrective action is, and it just becomes, if it's somebody's pet project, it's going to fail. It's got to be kind of rigorous. It's got to be looked at, and it's no small job done. It's not like just taking a vibration data and go, oh yeah, it's vibrating, change the bearing. There's a lot involved in it, and it's but the return on the investment is huge. Once you do it and you do it correctly, the payback is, like I say, it's can be every dollar you spend, you're getting $30 back. So
yeah,
my question is, why wouldn't you do it?
Yeah, and you know what? It kind of reminds me of, if you're gonna do it, you kind of have to commit yourself to a certain degree to really reap the benefits of it. Like if you if you went out for a walk around the block, you're not suddenly going to be able to run a marathon the next day. You're going to have to kind of build up to get to that objective, and you're sure going to feel super great and healthy once you're in that peak condition to be able to run a marathon. But it doesn't take overnight to do it. You can't just sample once in 2003, then once in 2010, and then once more and figure, hey, why did everything suddenly get better?
You got to stick with it. It's like then you'll reap the benefits. It's not something you just, okay, I'll try it for 6 months and then stop. You've got to keep up with it. It's a big investment in energy and time. But if you do it correctly, the results you'll be amazed.
Okay. Well, before wrapping up this podcast, I'd just like to see if there's anything extra you want to shout out or say to anyone who's listening in.
Get an assessment done. It's like, once you, like I said, the assessment is basically what drives the path forward. It's, I don't know. If you don't know what you don't know, it's, yeah.
Right. Yeah, of course. Well, everyone, that's Brian Harris. He's a consultant for TriBoro Consultants. I'll have his contact information, and if you have any questions for him, follow-ups, want to pick his brain about, more about what he's seen, questions, I'm sure he would love to get back to you. Brian, it was great to have you on here quickly for another kind of podcast episode that we have, and we'll be happy to share this with anyone who wants to tune in and watch it.
Okay, thanks for having me on.
All right, have a great day, Brian.
Thanks again, John.